Hello everyone, we are going to solve a question on reciprocal leveling. We all know that the benefit of reciprocal leveling, it removes errors of collimation, curvature of earth and refraction. So the given data is our instrument is say here at A, and staff reading at A is like this, and staff reading at B is something like this. Okay, so this is the ground level, so something like this is the data. This is our instrument station, this is A and this is B. So this reading we got 1.82, while pardon, I think I have drawn something wrong here because the slope is not going to be like this, so it's going to be something like this, because A is going to be little bit on the higher elevation side. So the reading at B is 2.72, whereas if we put our staff here, if you put our instrument station, then the two readings which we will get will be like this. Say here we are getting reading as 1.95 and this is 0.92. Okay, so we have to find out the RL of point B. So simply delta H, that is height difference between the two points, is given by the reading at B minus reading at A when the staff is at, when the instrument is at point A, plus reading at B minus reading at A when the instrument is at location B, divided by 2. So we will substitute these values, that is 2.72 minus 1.82 plus 1.95 minus 0.92 divided by 2. So let's find out. 1.93 divided by 2, 0.965 meter. So delta H is going to be equal to 0.965 meter. So since we already know the RL of A, this is 200 meter, so RL of B, which is going to be 200 minus delta H, that is 200 minus 0.965, it is 199.035 meter. So our one solution is 199.035 meter. So the next question is to calculate the angular error if the distance between the point is 260 meter. Since 260 meter is a very small distance, so we can neglect the errors due to refraction and curvature of earth. So and this is collimation error. Collimation error is going to be equal to the measured reading minus true reading. So measured reading when the instrument station is at A on the staff which is located at B, this is 2.72 meter, 2.72 minus the true reading which should have been that is going to be something like 1.82 plus 0.965, this is true reading which should have been there. So let's add these values, plus 0.965, 2.785 meter, so 2.785, this is true reading. So our angular error, that is collimation error, is coming 785 negative minus 0.065 meter. What does this negative value suggest? This negative value suggests that the error is negative and the correction required is going to be positive. So it suggests something like this, that say this is our instrument, the bubble is at center, then our line which should have been straight, that is it should have been straight like this, but it's not straight, rather a little bit shifted downwards. So this is measurement value, and this is true, that should have been there. So elevation is negative, downward shifting of line of sight. Okay, so this is collimation error, but what we had to calculate was the uh, angular error. So angular error is going to be error due to collimation divided by distance, mode value. So 0.065 divided by distance is 260 meter. So this is 10 theta, and it comes around 260, that is 2.5 into 10 raised to power minus 4. So theta is going to be equal to, well, this is the answer we require, but if in case theta is required, then also we can calculate the value of theta. And theta is going to be 51.57 seconds. So this is our first answer of angular error. This is the angle of error, this is the angular error. Okay, now we are calculating the second part, in which the distance is 2600 meter. In this, error due to curvature plus error due to refraction plus error due to collimation is going to be equal to minus 0.065 meter. So error due to curvature is this is a positive error, plus 0.0785 d square. Refraction error is negative 0.0112 d square, plus error due to collimation is equal to minus 0.065 meter. So let's substitute the value of d here in kilometers. 2.6 square minus 0.0112, 2.6 square plus error due to collimation is equal to 0.065. So let's calculate. So error due to collimation is coming around minus 0.5119 meter. Let me see it once again. Error was 0.065 meter. Yeah, it's coming negative only, angular error. Yeah, so tan theta will be equal to E collimation mode divided by d distance, that is 0.5199 divided by 2600. So we'll get some value around 2 into 10 raised to power minus 4. So theta will come around 41.25 seconds. Here also the value is negative, so that means the line of sight is shifted downwards. So it is something like that this is the horizontal, but the arc is shifted. So this theta collimation, and that is angular error, is 41.25 seconds. Thank you for watching my video.